Okay, so the next topic we're going to cover is transformations. Specifically today we're going to talk about translations. Okay, so for this section there's actually quite a few definitions, so you're going to need to write all of these definitions down. The first one is transformation. So a transformation is a function that changes the position, shape, and or size of a figure. Okay, the next definition is pre-image. The pre-image is a figure used as the input. So this is basically the before, like the original. Okay. Now our next definition is for image. The image is the output, which is basically like the after. So if you kind of think of the way a camera works, you have like a pre-image, that's the object, the original object, and then the camera produces an image, which is, it processes it, and the image is what you see afterwards. So like the pre-image is the before, the image is the after. Okay, now when we're doing transformations, sometimes the image stays the same size as the pre-image, sometimes it changes. Sometimes the positioning of the shape or the figure will change. Okay, so a lot of the times in the image you have some differences from the pre-image because either the size or the shape or the position of the pre-image has changed. Okay. All right, our next definition is rigid motion. All right, so rigid motion. This is a transformation in which only the position of the figure changes. So the size and the shape of the original figure are going to remain the same, just the positioning is going to change. So like the location or the orientation of the shape will change. Now our first type of rigid motion is called a translation. That's what you guys are going to be working with today. Now, a translation is a type of rigid motion, and it is a slide. So it's basically sliding a figure up, down, left, right, okay? But this is a rigid motion. So the figure is not going to change sizes. It's not going to change shape, okay? It's just going to slide. So the positioning will change in a translation, not the size or the shape. Okay, so what we're going to do in these examples down here is we're going to work through, okay, some different translations here, okay. Now, they've told us that they would like us to draw the image of each figure under the given transformation. So the transformation is a translation in which x and y map onto x minus 4, y minus 4. So what this means is here is my original figure. This is like the before. So this triangle here is the input, okay? The location of its points here are the x and the y. Okay, each one of these points has an x and a y. And so what the translation is telling me to do is take away 4 from each x value and take away 4 from each y value. So let's just look at an example of one point. Okay, point D, the coordinates are 2, 2. So if I were going to apply this translation here, it's asking me to take 4 away from 2. So 2 minus 4, my new point, which I'll call D prime because it's the image, it's no longer the pre-image, okay? So D prime, my new point, would be 2 take away 4. So 2 take away 4 would give me negative 2. And then 2 take away 4 here would also give me negative 2 for my new y value. So if I graph that point, negative 2, negative 2, okay, that is where D prime would be, okay? D prime is the after, okay? Now, essentially what I'm doing here is if you think about your x-axis, here's your x-axis, this is telling you take the original x value and move it 4 spaces to the left. So 1, 2, 3, 4, because minus 4 would imply going in the negative direction. Then it's telling you take the y value and move it 4 spaces down. 1, 2, 3, 4. Okay, so this is the location of my new point. So this is telling me, really what it's telling me is to go left 4 and then go down 4. Now I can figure out where each of these new points is by applying the coordinate rule, okay, or by just counting on the graph and shifting them, okay. So if I were going to figure out where n would end up, the coordinates for n are 4, comma 3. Then by applying the coordinate rule, okay, I would subtract 4 from the x value, so n prime would end up at 0. And I would also subtract 4 from the y value, so that would be negative 1. So my ordered pair would be 0 down negative 1 would be where n prime would belong. Okay, but I can also achieve this by just counting 1, 2, 3, 4 to the left, 1, 2, 3, 4 down, because that's what this is telling me right here. Okay. Now the last ordered pair was B, so the coordinates for B were 3, negative 1. So if I apply the rule, I can get B prime. So 3 take away 4 gives me negative 1. Negative 1 take away 4 gives me negative 5. So I can go left 1, down 1, 2, 3, 4, 5, and there is where B prime would be. Now, if I connect these dots, I get the same exact shape. It is the same exact size. It's just now in a different location. Okay, so if we take a look at this next one, okay, you can find the new coordinates by applying the rule to each of these points after naming each of them with their ordered pair, or you can simply just count on the graph by shifting each point. Now, what is this rule telling you to do? Well, plus 4 would mean on the x-axis we're going to go 4 in the positive direction, so that would mean we're going right 4, and then minus 3 would mean we're going down or in the negative direction on the y-axis, so that would mean down 3. Okay, what I'd like you to do right now is pause for just a moment, the video, and then try to figure this one out. And when you're done, play the video so that you can check your work. Okay, so go ahead, take a look at where the image of the shape would belong. And if you did the coordinates, okay, these were the original coordinates. These were the after, or so these were the pre-image, and this was where the image coordinates were, okay? And so if you just check, we're going right 4, down 3, right 4, down 3, right 4, down 3 from every single point, okay? All right, so in these two examples, we did a translation given a coordinate rule, okay? When you see the rule written like this is called coordinate notation of the rule, okay? Now, sometimes you're going to see the rule given to you differently, like in these examples down here. This time, the rule is given to you as a vector, okay? Now, what is a vector? A vector tells us the direction, okay, that we need to move the figure, okay? It also tells us how far to move the figure, okay? Like how many to go over, how many to go up and down, all right? So if I'm looking at this vector right here, this is telling me where to move this pre-image. So this vector is telling me go 2 squares to the left and 3 squares up to get from this point to the end of the vector, okay? So that means I'm going to take every point here and go 2 to the left, 1, 2, and up 3, 1, 2, 3. That would be where B prime belongs. Then I'll do V. 2 to the left, 3 up. That would be V prime, okay? And then 2 to the left and 3 up, 1, 2, 3. That there would be K prime. So now if I connect those dots, I now get my image, which is the same size, just in a different position, okay? So basically, this vector tells us direction, so this particular one is telling me 2 left and 3 up, okay? All right, so now what I'd like you to do is you're going to take a look at this vector here in problem number 5, and you are going to move this triangle according to this vector. You're going to translate the triangle, basically sliding it along this vector. So you need to count, okay, and then apply that to the shape. I'm going to have you pause so you can finish the problem. When you're ready to check your work, you can play the video. Okay, let's go ahead and check your work. All right, so for your work here, you should have been moving 1 to the right and then up 4 units, because in this vector, to get from the beginning to the end, we're going 1 right and up 1, 2, 3, 4. So when I do that to each point, these are the new locations of the points that I get. Okay? All right, let's go ahead and turn over to the back. Okay, so let's go ahead and take a look at numbers 6 and 7. It says use coordinate rotation to write a rule that maps each pre-image to its image. Okay, I can tell which one is the pre-image because the pre-image has no, I guess they look like little apostrophes. Okay, the image, these are the ones with the apostrophe. Or like a little like prime marking, okay? So the pre-image would be this darker one. The image would be this one next to it. Now, it's asking me to write a rule. So when I write my rule, it wants me to write it in coordinate notation, which we learned about on the other side of the page. So remember, coordinate notation, I start with x comma y, the original point, and it maps onto x, and then I write which direction I'm going. So if I'm looking at the number to put here next to my x, I start on the pre-image, and I look at how far I had to go left or right to get to the image. So from the pre-image, I went to the right 1, 2, 3. So that would mean +3. Okay, now when I look at the y coordinate, so I have y. Now to get to the new point from the pre-image to the image, did I have to actually move up or down? No, I didn't move up or down in this case. So I just only moved right. I didn't move up or down. So if I moved 0 spaces up or down, I'm going to write +0, but really what's y plus 0? It's just y. So if there's no change, then I just leave it the way it is. Okay. Now I'm going to give you a minute to check this, so pause the video, try to complete number 7, and see if you can get the answer. Okay, so let's talk about this one. Okay, this was the pre-image. It has no apostrophes. This is the image, so before and after. To get from D to D prime, I'm going to go left 3 and up 5. So I could choose this set of points, or I could choose another set of points. It doesn't really matter. In both sets of points, you're going to have the same rule, left 3, up 5. So to write that rule, that would say x minus 3, because I went in the negative direction going left. Okay, and then y plus 5, because I went in the positive direction going up 5. This would be your answer. Okay, let's go ahead and take a look at numbers 8 and 9. It says specify the component form of the vector that maps each figure onto its image. So this time what we're doing is we're trying to write down the component form of the vector. Now, the component form of the vector is basically a shortened version of the coordinate rule. Instead of writing the x and the y, we just write the numbers that we're moving, like -3, 5 would mean left 3, down 5. So let's take a look at this one here. You have the pre-image, and then you also have here the image. The pre-image is the before, this is the after. Now, to get from G to G prime, all I had to do was move right 1 space. So to write that in vector notation, I use these pointy brackets, okay, and it's written just like an ordered pair, but this is representing the change that I'm going in the direction of x for this first coordinate. So I moved right 1 unit, so that would be a +1. Now, did I ever move up and down? No. So I'm going to put 0 for my change in direction of y. I'm going to give you guys a minute to pause the video and try number 9. When you're ready, check your work. Okay, so let's go ahead and check your work. This was the pre-image. This was the image because this had all of the little apostrophes, the prime markings. So we're going to go ahead and move from B to B prime by going left 1, up 1, 2, 3, 4, 2, 3, 4, 5. Okay, so that coordinate rule would be I was going left 1, that's in the negative direction. So the component of the vector is -1, and then the y direction I'm going positive, so up 5, so +5. So here's your vector, -1, +5. All right, let's take a look at this last problem set. It says draw the pre-image and the image of each triangle under the given translation. So it gives you all the pre-image coordinates. We're going to go ahead and draw those. -2, 2, that's point A. -1, 3, that's point B. And then over 3, up 1, that's point C. So here was A, B, C. So now I'm going to go ahead and apply this vector. This vector is telling me to go left 3, down 3. Because negative would imply left, negative here would also imply down. So from this point I'm going to go left 1, 2, 3, down 1, 2, 3. That's where B prime is. Then I'm going to do A prime, left 1, 2, 3, down 1, 2, 3. Here's A prime. And for C, left 1, 2, 3, down 1, 2, 3. All right, so there's your shape. Okay. All right, you guys go ahead and try number 11. Pause so you can work on it, and check your work when you are ready. Okay, so I've gone ahead and graphed the original triangle. So here is the pre-image. I'm going to apply this vector. This vector is telling me to go right 5 and then go up 1. So I'm going to go right 1, 2, 3, 4, 5, up 1. That's Q prime. Right 1, 2, 3, 4, 5, up 1. That is R prime. And last, right 1, 2, 3, 4, 5, up 1. That is P prime. So now I can go ahead and connect those points. Maybe I should move the original R letter over here so you guys can see that's where it belongs. Okay, so this is what your image should look like.